Hello everyone, this is Teacher Emmanuel Mugalia and I welcome you to our Learn Chemistry series. In today's video, I want us to discuss precipitation reactions in relation to ionic chemistry and qualitative analysis. And the key objectives of what we are going to discuss today will be in our precipitation reactions. Someone at the end of it all should be able to state the observations made at the end of a precipitation reaction. Someone should be able to predict the products of the reaction that we obtain at the end of the precipitation reaction, and at last one should be able to write the ionic equation that is obtained in terms of the precipitation reaction. However, today we want to concentrate on one type of precipitation reaction, that is going to be precipitation of the hydroxides, and we shall be using sodium hydroxide. So from these precipitation reactions, we are going to see two solutions mixed together, and then we come up with a solid product, because the precipitate is that solid product that is formed when we mix up those two solutions, and then we precipitate out a solid substance. We are going to use the following salts, and the materials that we shall use. Those salts are displayed to us here. We have the water to dissolve the salts. Then also we have the sodium hydroxide, which is the key reagent that we are going to use because we are interested in precipitating out the hydroxides. Here we have the salt, magnesium sulfate. It is one of the salts we have there. The cation that is present in magnesium sulfate that we pick out from here is the magnesium. The magnesium cation is what we obtain there. And it is a 2+. Then we shall also use aluminium sulfate and use it with sodium hydroxide and see what takes place. And the cation of interest in this is aluminium 3+. Aluminium 3+, because aluminium forms such kind of cation. Then we have also the lead 2 nitrate. The lead 2 nitrate gives us a cation which is lead 2+. Then the zinc chloride gives us the cation which is zinc 2+. Why are we picking out the cations of interest? Because the precipitation of the hydroxide is going to be in relation with the metal cation combining with the hydroxide of sodium hydroxide. Then we come up with a particular product. The precipitates are the ones that we shall use to predict other products, at the same time to come up with ionic equations of the reaction. Now let us first go through the practical part of it before we come back to see the other theory behind writing the ionic equations. So let's get started. We dissolve a salt. After dissolving a salt, we shall now be coming to add sodium hydroxide. Dropwise, and we see what takes place. Then we bring the excess and see what takes place. At the end of it all, this dropwise must be able to precipitate out what we want, and we come up with the ionic equations. So we get started. We have our 4 test tubes here. These 4 test tubes will help us dissolve the salts of interest. We have the salts of magnesium. We have the salt of lead that we shall have here. We shall have also a salt of aluminium, another salt of zinc. So let's see what takes place. We pick a spatula end full of, this is magnesium salt, so we pick a spatula end full of magnesium, or just a small amount, and have it in that. Then we also pick a spatula end full. This is our aluminium salt, which is aluminium sulfate. So we pick a spatula end full of aluminium sulfate, and also we dissolve. We shall dissolve it with our water, that is aluminium. Then also we pick something from lead. We pick our lead salt. The lead salt is this from our label. So we shall have lead in that. And lastly, we pick the zinc salt. We pick the zinc salt. Pick a small amount and put it in our test tube there. So we have our salt substances. The next thing we do is to dissolve them. Why are we dissolving them? Because we want to come up with these cations. When these ones go in solution, they release these cations, and therefore these cations will be able to react and precipitate as we want. So we come and pick. I start with the magnesium salt. The magnesium salt, we add some water there. Add some water there and dissolve. We simply shake to make it dissolve. So that is what we have in terms of magnesium. That's our magnesium salt. Next, there is this salt of lead. We also add some amount of water and we shake to dissolve. We have picked lead to nitrate. Don't forget that. We shake to dissolve. Okay, add some little amount of water. That is the lead. We leave it there. Then we pick aluminium. Still, we add some water to dissolve it. Small amount. You shake. The shaking is simply permitting the dissolving to take place. Okay. Add some more water to allow dissolution to take place. This is aluminium. We put it there. Then we also have the zinc salt. Zinc salt, we add water and then shake to dissolve. Okay, that's what we have. So that is our zinc as well. From that, what comes next? We shall be picking just a small amount, small cubic centimeters of each of these salts. We put it in a given test tube and then add sodium hydroxide. Let us start with the magnesium sulfate. The magnesium sulfate, we pick the magnesium salt, is this. So magnesium salt, we pick a small amount. That is enough. That's magnesium. And the next thing we pick sodium hydroxide is what we are going to add. Don't forget we are going to add dropwise and see what takes place. Then the excess, what shall we see taking place? So we have this, we add dropwise. When we add dropwise, what do you see? The color has changed, just drops. The color has changed and is giving us white. Now this is not white solution. You can add more amount and see. This is not white solution, but instead we call it a precipitate. Something that is not dissolving in solution is what we come up to say a precipitate. So we are seeing dropwise, it is giving us a precipitate. What about if we bring excess and still try to shake? No change is taking place. So that is what we have. Still in excess, even though you try to shake, nothing changes. So we come up to say that when we have magnesium sulfate combined with sodium hydroxide, that salt generates an observation we see as a white precipitate. White precipitate. That is the dropwise addition. Then in the excess, from what we have done, it shows that the precipitate that has been formed is insoluble. It is insoluble in excess. That is for magnesium. The next salt we have is aluminium. We come back and still follow the procedure. We pick a clean test tube. We pick the solution of aluminium and just pick a small amount. When we pick a small amount, that is what we have, a small amount. This solution is colorless. So we have the sodium hydroxide. The sodium hydroxide is here. We come and put just a drop. When we add the drops, what do you see? There is a white precipitate still that has been what? Formed. When you just add the drops, then when we bring the excess and you try to shake, when you bring excess and you try to shake, what do you see that has taken place? The solution has turned out to be what? Colorless. So we come and report what we have seen. For aluminium 3+, the observation in dropwise, it is a white precipitate. That is dropwise addition. Then In excess, what we have seen as being a colorless what? Solution. Colorless solution is what we have seen. That is for aluminium. Next, we come and bring this one is our zinc. We come and bring zinc. We pick a clean test tube, and add a small amount. Add a smaller amount of the salt. That is our zinc. Sodium hydroxide is back. We add drop-wise and see what takes place. When you add the drops, what do you see? We see that there is a white precipitate that has been what? Formed. Just drops. Then when we come and put excess, and try to shake, what do you see taking place? What we have is becoming colorless, and finally it turns out to be what? Colorless. That is our zinc. So we also come and report this zinc gives us a white precipitate. It gives us a white precipitate if we are adding in dropwise addition. Then in excess, we are seeing that it has given us a colorless solution. It has given us a colorless solution. The last salt we want to see is lead. Lead is here. We pick our clean test tube, a small amount of lead. That is enough. That is our lead. We come and pick sodium hydroxide, add drops. We see what takes place. We can clearly see that drop-wise, it is giving us what? A white precipitate. Then if we bring in excess, what will take place? Put excess and shake. Excess and shake. Give it some time to settle. Excess and shake. What do we see next? We can see that what was originally as a white precipitate is now turned out to be what? A colorless solution. So we come and also report that for the lead, in dropwise addition, it gives us a white precipitate. And then this side of excess, it also gives us a colorless solution. That's what we have. So from this, I want us to see observation, rather the study objective want to be clearly spelled out. Where we have said one of the objectives we want to meet today is to state observations. So if we have sodium hydroxide added to a magnesium sulfate salt or any other magnesium salt, what do we observe? Dropwise addition gives us a white precipitate. Then in the excess, we come up with the insoluble part of it. So how do you state the observation in that? If we are adding sodium hydroxide dropwise and then in excess, we come to see that a white precipitate is formed insoluble in what? Excess. If we have sodium hydroxide added to an aluminium salt that is soluble, what we observe? Dropwise until in excess, we get to see a white precipitate soluble in excess to form a colorless solution. The same trend comes for lead and zinc. They are white precipitates soluble in excess to come up with a colorless solution. So that is the first objective that we have seen, that we can state the observations that are made during this kind of practical outline that we have seen. Now we want to see objective 2 and objective 3, that is predicting the products formed at the same time writing the ionic what? Ionic equation. The ionic equation is going to concentrate on this section that has a dropwise addition. That's where we are seeing the precipitate. Because our study today targets precipitation of hydroxides. So we want to see how can you come up with the ionic equations for these precipitated what? Products. So let us start with magnesium. When we have magnesium added to sodium hydroxide. So we want to come up with our second objective and third objective. Let's see. We have magnesium sulfate. That is what we have, aqueous, plus this magnesium sulfate is reacting with the sodium hydroxide. So predict the products that are formed. So step one, what do we do? Someone must be able to come here and split this. We see what can come out of what we are having. So this side, in this solution, means that we have this positive side that has the metal, which comprises of magnesium. Then we have this other side that has the radical, which comprises of the what? Of the sulfate. But we have seen this one is a 2+, so we come and put it 2+ there. This radical is a 2-. That is what takes place in solution. Then also this sodium hydroxide solution, how is it appearing? How does it give us its species in solution? We bring still, the positive side is this side, so we come and bring that sodium. Sodium is a positive charge. Then we have this radical side which has the hydroxide, which is that. All of this is in solution. This is in solution. This is in solution, aqueous. Even this side we have what? Aqueous. What are the possible combinations that we can come up with in such a case? The prediction of the products that can come out. This one has already been combined with this, so these two cannot combine to give us the product. So what comes next? Can this combine with this? A positive and a positive, they cannot combine. So we leave that one out as well. But this one, can it possibly come and combine with what is this side as the hydroxide? So that is our first combination that we come up with. So we have this combining with that. Someone seeing this with this, automatically you get to know that I'm dealing with a product of magnesium hydroxide. That's the first combination that can possibly come out. Then automatically what is remaining behind will react and combine with each other. So we have that combining with that. Those are the possible combinations. So from this, we predict our products. The first product that we have is magnesium hydroxide. Take note what comes back in this now. Writing the chemical formula of a compound. Someone must be able to write the correct formula of magnesium hydroxide. So if you combine this with this, let us try it out here. Magnesium, from what we are seeing here, its valence is what? 2. It can be picked from this. Then the hydroxide is valence what? 1. It can be picked from the charge that we are seeing there. It's -1. So when we interchange this with that, we come up with magnesium hydroxide, which is that. So this one is our first product that we are seeing, that we have correctly predicted. So we come up with that and write it here as magnesium hydroxide with a 2. It is the precipitate, so it takes up the solid what? State. Plus, this has been our first prediction, which is that. What comes next? The sodium must combine with the what? With the sulfate. But still someone, we erase this, someone must be able to know how to write the correct formula of sodium sulfate. So sodium, from what we are seeing, the valence there is 1. Then the sulfate, when we come up with this radical, the valence is what? Is a 2. As we go back the rules of writing chemical formula, we interchange. This one comes here, then the other one goes to the extreme end. But the one doesn't change anything. So this one automatically tells us that our final formula will be the sodium 2 and then what? The sulfate. This is our second product. So you come and pick it from here and write it here. That this is sodium sulfate, and all this is what? Aqueous solution. This aqueous it is not observed from what we have seen. We have been observing the precipitate. So this one appears together with this, but the precipitate covers up its appearance, because the color is what? Solution. So that is what we have. We have been able to predict our what? Products. Then how do we write the ionic equation as our third objective? To write the ionic equation, number 1, after you predicting the products, make sure you can be able to balance the equation. From balancing the equation, we shall bring the other concept of writing the ionic equation. So from what we have seen, magnesium this side is 1, magnesium this side is also 1. The sulfate this side, I'm taking this as a whole, the sulfate here is 1, even this side we have the sulfate as 1. Next, the sodium here is 1, but the sodium this side is 2. So we interchange those factors. The one doesn't affect anything this side, but when this 2 comes here, it changes something. So the sodium is also balancing 2 sodium atoms, 2 sodium atoms. Then at last, we want to see, we are taking this as a whole, a hydroxide. So this 2 multiplies the whole of this hydroxide. So there are 2 hydroxide radicals this side, then the hydroxide radicals this side, how many are they? There are 2 because of that 2 that is written down there. So from this, we now have our balanced equation. Next step is, what are the rules of writing coming up with this ionic equation? Something that is aqueous separates into ions. For example, this is aqueous, so it has separated into magnesium 2 plus ions. It has also separated to give us the sulfate what? Ions. We have this one, it has separated to give us the sodium ions. It has also separated to give us the hydroxide ions. A solid does not separate into ions from what we are going to do today. A gas does not do the same, and a liquid substance does not also separate to give us what? Ions. So from this, someone must be able to know that I'll have this separated to ions, I'll have this separated to ions. This one will not separate into ions, but this last one will separate into ions to give us the sodium ions and then the sulfate what? Ions. And because of the balancing, someone can therefore bring how, if 2 is here, it means these sodium atoms are how many? They are 2. And if 2 is here, the hydroxide atoms, the other radicals are also what? Are also 2. We put it there. This one remains the way it is. Don't forget, we are on the third objective of writing the ionic equation. This one remains the way it is as a solid. Then this one comes and separates. If we separate it, what do we come up with? There are 2 sodium atoms. So in solution, we shall have 2 sodium ions. This is also aqueous. I have it there. Then we have the other side of the sulfate, which is the sulfate ions. And that is what we have. Next step, as we generate our ionic equations. We have to outline everything. We add up this and go to the other side of the products. So we shall have in our ionic equation, we bring magnesium 2 plus aqueous plus we have the sulfate ions, which is that it is also in solution. We have 2 sodium ions, which is that, plus we have the 2 hydroxide ions, which is that. This one gives us, this one remains the way it is, that's what we have agreed. So we have the solid precipitate, which is magnesium hydroxide. Then we have these ions, 2 sodium ions, and lastly we have the sulfate ions. This is aqueous, this one is also aqueous. Next step, we cancel out what we call spectator ions. If we see an ion appearing on the reactant side, at the same time it is appearing on the product side, but when it is exactly the same, it means that one is a spectator what? Ion. So we cancel out those spectator ions. We go slowly. Magnesium 2 plus is this side. Look for magnesium 2 plus this way. It is not anywhere. So that one remains. We have the sulfate 2 minus appearing on the reactant side. We also have the sulfate 2 minus appearing on the product side. So those are spectator ions. So that one cancels with that. I want you to look at this as elementary a mathematical expression or equation. So that what is this side cancels out with what the other side. Next, 2 sodium ions appearing on the reactant side. We also have 2 sodium ions appearing on the product side. So they cancel out. We refer to these as spectator what? Ions. 2 hydroxide ions on the reactant side. We don't have the hydroxide ions freely this side of the what? The products. So we leave it at that. And what comes out as the net equation? The net equation therefore becomes, we have remained with magnesium 2 plus aqueous, combining with, these ones have cancelled out, combining with the 2 hydroxide ions. And what does it give us? What has remained on the product side? What has remained on the product side is magnesium hydroxide, which is our solid precipitate, which you have observed as the white precipitate. And this is what we call ionic equation for that reaction. That is for the first salt, which is magnesium sulfate. And that is our ionic equation that takes place. So from what you have so far done in coming up with the ionic equation of this magnesium sulfate, I take it that someone can be able to outline the ionic equation for the precipitation of the solid using aluminum sulfate, for the precipitation of the solid using Lead nitrate, and for the precipitation of the solid using zinc chloride. Recall, what are we precipitating? All these white precipitates that are coming out are hydroxides of the metals within the salt. So try out and see that things can come out. The 3 objectives must be observed in whatever you are doing. You can study the observation, you can predict the products, at the same time you can write the ionic equation very well. Thank you for watching. Next time we shall look at colored salts and see what comes out in terms of the observation and see the outline.